Now another move is to go to what's called the CIM, or the Common Information Model. This has been proposed by the Desktop Management Task Forum, or the DMTF. It would support HMMS, and as I say, it's known as CIM or SIM, the Common Information Model. Permits management data that is gathered from a variety of enterprise and desktop voice and data technology to all be transported, processed, displayed, and stored by a single SIM-compliant web browser. Management data to be used by the SIM would be stored in what they have, another proprietary format, or I should say not proprietary necessarily because this is open source, but just another format, which is the modified object format. So think of that as the MIB and the MIF. So the MOF now. You got the MIB, the MIF, and the MOF. Just know which one goes where. So MIB goes with enterprise management systems, MIF goes with desktop management systems, and MOF goes with the CIM SIM. And this is just a graphic kind of representing all the pieces interoperating within the entire enterprise here. So some components may support the SIM, so we go ahead and use the SIM. Some may only support the desktop management interface, and so we use the desktop management interface. Some components may only support the DIMMs, really, the MIBs, and utilize SNMP then to transport their data back. Now, SNMP has some problems with it. One of the things is when the management system sends out a request to a device to get some information from it, if that device doesn't support that particular information or has no new information to offer, it won't respond. And so the management system then consistently starts polling for that information to come back from the device. And so that increases the traffic on the network. So constant polling is one problem with SNMP. Also, they didn't have any manager-to-manager communication, so SNMP, using the original SNMP, only had one management console in the mix. It was limited to only using the TCP/IP protocol, so if we wanted to use IPX, SPX, which remember was in the Novell networks, if we wanted to use, say, Apple Talk in an Apple-based network, then SNMP didn't provide support for that. Now, most of those that I talked about, Novell and Apple, also have TCP/IP as a native protocol. So all they have to do is load up TCP/IP and then utilize SNMP. Pretty much nobody uses those other network protocols anymore. Also, it didn't offer any security features. So all the data that you're retrieving from your systems could be intercepted and utilized by someone who you wouldn't want to have access to that data. This really isn't anything more than what we've seen in the past here. What they're really trying to show you is that by using SNMP, we only had manager and agent communication. So the idea with the original SNMP was that all these different devices have their MIBs on them, and pretty much everything here is going to be MIB based. And they would all use their agents to then come back to one management console, which then gets stored in their management information database. That was using the original SNMP. They came out with SNMP, typo there, SNMP 2. SNMP 2's major objectives would be reducing network traffic, so reducing that constant polling problem, segmenting large networks, so be able to collect within groups of LANs, support multiple transport protocols, increase security, and allow multiple agents per device. You know what? I'll have to check that in the book. It says multiple agents, but they meant multiple managers per device. I think the book had the error there. SNMP 2 offers what they call a bulk retrieval mechanism. The managers can retrieve several pieces of network information at a time from a given agent. That was the other problem with the old SNMP, is it would only request one piece of information per transaction between the management and the device. So with SNMP 2 now, the management system can say, I want a whole bunch of information, all different pieces of information in one request, and then get a response back from that. Agents have also been given increased intelligence, enables them to send error or exception conditions to the managers when a request for information cannot be met, so that reduces that polling issue we talked about. With SNMP, agents simply sent empty datagrams back to managers. We talked about that. The request of the empty packet merely caused the manager to repeat. So all of those last three really just deal with the whole polling issue. So that's polling and the ability to get more information at one grab. And so again, SNMP2 has given us now the ability to have managers, the actual management systems, exchange information with each other. And it just makes it much more productive so that we can have multiple management systems throughout the network. More people can retrieve and process the data. SNMP2 then allows the establishment of multiple manager entities within a single network. As a result, large networks that were managed by the single manager under SNMP can now be managed by multiple managers in a hierarchical arrangement. So you can actually have one manager that collects from other lower level managers. Overall network traffic is reduced as network management information is confined to the management domains. So think about that too. If we've got 3 or 4 different LANs and they're all connected by WAN links and all that data has got to be collected from all those LANs to come into one management system, well, we're tying up all those WAN links every time that we're pulling that data across there. So instead what we're doing is we're collecting it right at the local area networks, and then in a low time, maybe midnight, 2 a.m. in the morning, they can go ahead and exchange the information with a higher level management system, a centralized, the major domo, so to speak, at the top of the hierarchy there. And so there's just a graphic representing that. Now we have a management system at each local area network. So this is one grouping here. You got your bridge, your router, your communication server, all delivering to a management system. Basically the same thing here, same thing there. And then at the top of the hierarchy, a management system that collects from the lower level management systems.